Hello, welcome back to 7-6 integrating the natural logarithm function. And what we're going to be doing in this video is specifically integrating natural logarithms. In the last video, we kind of worked backwards, right? The derivative of natural log is 1 over x. So we were going from 1 over x to natural log. Now we're going to be actually integrating natural logs. What do we do? All right, so first, when you're integrating functions that contain logarithms, what we're going to have to do is think about reverse chain rule. With the natural logarithm, the derivative of that is 1 over x. So if we see a natural logarithm, what we're going to have to do is we're going to have to go ahead and account for a 1 over x. Okay, so for example 5 here, I want you to see that we have the integral of natural log of x, okay, and again, if the natural log of x is u, then its derivative, right, or its hook is 1 over x. So I'll just separate these as this, and what I want you to see here is, hey, I mean, I have the hook already accounted for. I have that 1 over x. So when we go ahead and integrate this, I'm going to integrate the natural log of x, and we treat natural log of x just as a function. It's natural log of x to the power of 1. So this becomes the natural log of x quantity squared, and again, this is an indefinite integral, so I have to have plus c. Okay. Oh, and 2, when we raise the power, right? When I raise to the power plus 1, you have to divide by that new power. So here you go. Natural log of x squared divided by 2 plus c. There is your answer. All right. Example 6. Again, I'm going to go ahead and I'm going to integrate this. And I want you to see that we have 1 over 2 minus the natural log of x quantity cubed times 1 over x dx. Okay, and if I look at this denominator here, okay, again, u is equal to 2 minus the natural log of x. Okay, then u prime, I almost wrote du, I'm getting ahead of myself. U prime is negative 1 over x, right? So, okay, well, I mean, I have the 1 over x. What I'm missing is the negative. So what I have to do is I have to go ahead and, well, first I'm going to rewrite this. Minus natural log of x to the power of negative 3 times 1 over x dx. Okay, and I need that 1 over x to be negative, so I'm going to introduce a negative, okay, and you have to balance it. So I'll balance it on the outside. So I just introduced 2 negatives, right? So it's equivalent. Okay, so look, I have the hook. Here's the hook. Okay, when I integrate, that's going to go ahead and go away. So I integrate, and I get negative 2 minus the natural log of x. The power is going to add by 1, so I raise to the power negative 2, and then I'm also going to divide by negative 2 plus c. Okay, and you can rewrite this if you want as 1/2 times 2 minus the natural log of x to the power of negative 2 plus c. And there's your answer. Okay, so that is integrating with the natural log of x. Okay, whenever you see it, again, you have to account for its derivative when you're integrating, right? That's the reverse chain rule. All right, and now what we're going to look at is example 7. And example 7 doesn't match the top 2 problems. It's a little bit different. Here, I have the integral of 1 over root x minus 1 dx. And what we're going to do here, again, whenever you have a square root, kind of something to think about, especially in the denominator, is we're going to be utilizing u substitution. So here is our wonderful u substitution. Okay, I'm going to say let u equal the square root of x. Okay, and I also need to, again, that's step 1, right? I need to identify the second thing. I need to identify what's x. Well, if u is root x, then u squared is equal to x. And the third thing, again, what is the derivative of each side? So 2u du is equal to dx. Okay, so those are the three things. Now we're just going to go ahead and plug them in as necessary, right? I'm going to substitute in u for root x, and then dx, I'm going to substitute that back in. So let me go ahead and rewrite this. So this is the integral of 1 over u minus 1, okay, times 2u du. All right, and actually I don't want to write it like this just yet. I'm gonna write it like this. So 2u du. And now you're looking at this and you're like, well, I mean, what good did that do? I have powers that are the same. Well, what did we say in the previous video? When you have a degree of the numerator that is greater than or equal to the degree of the denominator, we have to utilize long division. So I'm going to go ahead. I have to go over here to the side and do some long division. U minus 1 divided into 2u. That's 2, giving us 2u minus 2. Change your signs, and I get a remainder of 2. So this is equal to the integral of 2 plus 2 over u minus 1 du. Okay, so I'll go ahead and integrate. So the integral of 2 is going to be 2u, right? I'm integrating with respect to u. Plus, now here I have 2 times, this is essentially 1 over x. Think about it as 1 over x, which would be the natural log of the absolute value of u minus 1, okay, plus c. Now, are we done? No, I mean, in terms of u, right, I wanted to integrate with respect to x, so all I have to do is go ahead and resubstitute. So u was equal to the square root of x, right? So I have 2 root x plus 2 times the natural log of root x minus 1 plus c, and voila, there it is. All right. In this video, again, we integrated the natural log of x. Again, when you integrate natural log of x, you have to account for its derivative using the reverse chain rule. So you have to look for that 1 over x and utilize either reverse chain rule method or use substitution. All right. Hope you enjoyed. Catch you next time. Peace.